Hey guys, welcome back. Today I'm going to be doing a math video. Very weird, I know. So, first I'm going to be teaching Riemann sums, specifically the left Riemann. I don't even know what this stands for, but I know what it means, so that's all that matters. So, basically, we are trying to estimate the area under a curve here using rectangles. And the more rectangles we use, the more accurate it's going to be. Say we have this curve 2 over x. I don't know exactly what it looks like. We need to estimate the area between 1 and 5 with 4 rectangles. That's what this n means. And the LRAM, we're going to be using the left side of the rectangle to do that. I'll show you what I mean. So first of all, we have to find how wide are the rectangles. That's the first thing. So we're going to take, it's kind of like y2 minus y1. These are x coordinates though. 5 minus 1, it's kind of like that formula, just so you know. And then we're going to put n, which is for the amount of rectangles, there. So now we have 4 over 4. So we have 1, we have a width of 1 per rectangle. This is kind of an easy one to start out. So I'm going to, first of all, draw 4 rectangles here. A little bit uneven, but doesn't matter. And then, as we know, it's between 1 and 5. And it's also a width of 1 for each rectangle, so we're going to add the rest because there's a gap of 1. So it's going to be 1, 2, 3, 4, 5. Now, next thing. How do you find the intended height for this? Well, first of all, we're going to use the left, as I said, the left number for each rectangle, which would be 1 for this one, 2 for this one, 3 for this one, 4 for this one, and 5 is basically meaningless in this problem. So how are we going to do that? So we're going to plug these into the equation. So we're going to plug in 1. So it's 2. 2 is the intended height of this rectangle. 2 is the intended height. And how much was the width? It was just 1. 2 minus 1 is 1. So 1. Or I should draw this here. It's just going to be 2 is the area of this rectangle. And now you want to keep doing this equation for the left side because it's LRAM. Equals 1. So intended height of 1 at 2, the x-coordinate 2. Intended height of 1, and again, width of 1, so always going to be a width of 1 for this problem. Now 2 over 3, the 2 over 3 times 1, 2 over 3. Now 2 over 4, what is that? 1/2. 1/2 times 1, because width of 1. Just going to add these up. And we'll get something like 4.166, something like that. So that'll be our answer for this one. There you go. Okay, now we're going to be trying another one, except this time we're going to do RRAM. Because you guys remember, we were trying to find the intended height of each rectangle using the left side of the rectangle. Now we're going to be using the right side of the rectangle. And we're also going to change this to negative 1/2 x squared, because that's simpler, at least for me. And so we have 5 rectangles. First thing that we can do here, 2 minus negative 3, which is 2 plus 3, over number of rectangles equals 5. 5 over 5. Oops. Equals 1. So that'll be our width once again. That's kind of boring, I know. But that's just to get a feel for these. It's very important to get a feel. This isn't going to be very accurate in terms of the height. So we have 5 this time instead of 4. It's a little wonky. But so we start from -3, and it's 1 width per rectangle. So -2, -1, 0, 1, and 2. So now at this point, what we're going to be doing is, as we did last time, plug into the original to get the intended height of each rectangle. But we're going to be using the right side. I almost used the left side. Sorry about that. We're going to be using the right side of the rectangle to estimate that height. So oh, I did that again. Oh, sorry. -4 over 2 plus 6. -4 over 2 is -2 plus 6 equals 4. Oops. So 4 is our intended height for this rectangle here. So then the width is again 1, so multiply that, because you know the rectangle formula and square formula, right? Yeah, just length times width. We're going to be doing the same thing. Remember, take the right side because it's an RRAM problem, not an LRAM problem. So negative -1/2 plus 6. What is that? -1/2 plus 6. It's just 5.5. 5.5. And then do it for 0 here. -0 squared, that's just going to be 0 plus 6, so 1 times 6, 6. 1 negative -1 squared. Oh god. -1/2 plus 6 is lo and behold 5.5 again. Times 1 is just 5.5. And then we're going to be using 2 here. Negative. It's getting a little messy. I apologize. -4 over 2, which is -2 plus 6 equals 4. Same as that. 4. Just add all these together. You'll get 25. Okay, so now we're going to be doing an MRAM problem, which is going to be finding the intended height from the middle of the rectangle this time. And we also have 4 rectangles that we're going to be using. So first of all, again, 3 minus -1 over 4. Oh, it's always 1. I'm so tired of this. Well, these are like some of the easiest ones, so that's probably why. But of course, you're going to have to change that once you get a width higher than 1. You're going to have to multiply by another different number besides 1, besides itself, besides just, the height. So we're going to separate 4 rectangles. These aren't the correct height, by the way. These are not supposed to be the same height. I'm just drawing that for simplicity. The curves are really like, I don't even know exactly what this curve looks like, but yeah. So -1, 0, 1, 2, 3. And now we're going to be doing trying to find the intended height by plugging in 0.5 or -0.5 specifically for this value in here. And 0.5, plug that in, 1.5, 2.5, because we're doing the MRAM, the middle, using the middle to find the intended height. So -0.5 squared minus 2. Oh, excuse me, this is supposed to be negative. Get rid of that, I don't know. Two times -0.5. Oh, go away, no. the result of this is 4.25. So I think you guys get the idea. You know, plug in 0.5 into this, plug in 1.5 to that, plug in 2.5 to that. I'm going to do that. I already have the answers here. I just don't want to be putting this on the screen, you know. So plugging the midpoints of these rectangles, you know, here, into the original equation, because this is an MRAM problem. This is the result. So now we have a different kind of problem. I know you might be tired of those old problems. So to start out, I'm going to be introducing a formula to solve this. Okay, so now I have a formula here, which is basically, this is just sigma here. The n is the number of rectangles. This will either be k or I. It'll be equal to 1 in this case, n to infinity. And the reason why it goes to infinity is because if we have the number of rectangles at infinity, we can make it extremely accurate when we estimate the area under a curve. If we have infinite, it's going to be very accurate. So next we're going to do b minus a, this b minus a. And the number of rectangles, in this case we do not have the number of rectangles, so that'll just be n. And we're going to multiply the f of, or plug it into the equation, the starting point, which is the lower limit, which is 1 in this case. This is also the lower limit here. Right here. Lower limit plus k, you multiply k by what we had here, b minus a, over number of rectangles. And yeah, let's put that into action. So in this case, we have to write it in summation notation. So this part of the equation, of the answer in summation notation is going to be the same, the one I'm writing right now, no matter what problem we're doing, at least right now. K equals 1. And then this is where it all changes. So, because you have the formula b minus a, 3 minus 1 over n, because we don't have the amount of rectangles, it's just going to be 2 over n. So, this one is 2 over n. Next, we want to do the f of the start, just having the start right here. So f, we're going to just sort this out before we get into this should be bigger. First of all, we want to find what this is. So 3 minus 1, of course, is 2. 2k over n. So now you want to, of course, the f of blank, this is what we're going to plug into this equation here. So 1 plus 2k over n times 1 plus 2k over n. I think we shall just leave it as this. It's just squared. I don't think it's worth multiplying that all out. And guys, do remember this, the constant at the end of this equation. That gets included as well. Oh, put it in squared. Okay, that's not that clear. So the final answer is limit as n goes to infinity, sigma n, k equals 1, times 2 over n, times in squared, all squared, 1 plus 2k over n. Now we're not in squared anymore, plus 3. So yeah. I'm not going to do another problem with this one. Now we have to do the opposite. So how are we going to do that? Well, first of all, what is the starting point? Right here. This in our formula, that's where the starting point is. Right here. So, oh yeah, also additionally, we're writing this as an integral. I completely forgot. So we're going to be the upper limit, upper limit. That's how we have to write it. Because I'm sorry about that, but the other one was in words, but now we have to do in integral form. The form and then f of x, because this is literally the same thing, but we just have to convert between the two. This is a more simpler version. Up, down lim, which is limit, up a lim here. So what do we have so far? Starting point, as in the formula that we had before. The b minus a over number of rectangles times f of start plus k times b minus a over number of rectangles. That's our starting point. Yet again. So we're gonna be or as also known as the lower limit, the lower number, which is 1, and then we have some other number, just any number. This probably should be a number sign. So this on the left side is the lower limit, and this is the upper limit, whatever number this can be. So now we have to take care of this. Oh yeah, also I is the same as k. So if you really think about this, so remember the formula that was right here, b minus a over n. Number of rectangles. This is the same thing. So what was our a? A is our lower limit. 1 over n. And disregard the I here, because k was just multiplied by this. So you see what is right here? Oh yeah, also right here as well. So this is the first part of the formula. So you have to equal to that, and then you can pretty much get what's b minus 1 will be 3. And guess what? B is our upper limit. So remember, take it from here. This is, remember, this was b minus a over number of rectangles. Of course, we don't know in this case. So just remember that. Equal to the lower limit is right here in the equation, is a. And then you can find b with these two and disregard this. That's just multiply to it. So now, we have an upper limit of 3. Now the last thing to tackle is the f of x equation. Remember we dragged over the constant from the original that didn't have an x? We're going to put plus 1 because we just drag over the constant because there's no x. And also, we don't have anything multiplied on this end. Nothing multiplied here. No fraction, no nothing. Nothing. So what can you assume that this is if we don't have anything multiplied? By this. By f of x. Let's say f of blank. What's in here? So we have nothing. Nothing multiplied by what we have in the parentheses. So what do you think we're going to have? We're going to have an x. And, add the squared. Because that's here. If you forgot things from before, you can always go back. So this is our answer here. So that's pretty much what you have to know. There's some applications, but you can definitely figure those out with what I've talked about in this video. You can figure out those, there's a word problem. There could be some word problems. So you can easily figure that out with the rectangle, what I talked about earliest in the video. I would like to wrap up with just a quick lesson on something else. How do you find the integral? Say like a basic function, like 4x. This is not going to be in standard form. This is a little bit ahead of the game, but it's good if you know this early. So remember derivatives where we would take the x away and then we multiply the 2 by that? This is the exact opposite, antiderivative. Same as indefinite integral, which doesn't have any limits. You're not plugging any numbers in. You're just finding the antiderivative. You're not plugging in the numbers at all. So I'll show you the difference between indefinite integral, which is what we're doing right now, and a definite integral. So this is how you do it. Take the 4x. So here's the thing. Instead of multiplying the exponent by here, by this number, and then subtracting 1 from the exponent, we're going to multiply the reciprocal of the exponent that we want to go up to, which is plus 1. This is degree 1, so plus 1 is 2. So we want to take the reciprocal of that, multiply that by 4x. So 4 over 2x, and then, 1 plus 1, you want to add up degree by 1. Add 1 degree, 2x squared. Same thing for 1/2. 1/2. And then take the reciprocal of the decimal, or the degree that you want to go up to, which is the original degree plus 1, which is 3, equals 1/6 x, cubed. And here. Oh, also, remember? There could be a constant in this equation that we get rid of that you won't see in this equation, but there's no way you can figure it out because it's not in we're just going to call this the original equation here and call this the derivative for just this moment. But say you have like 2, for example. Say you have 2. When you take the derivative of this equation, which would be this, it's not there. And you can't figure it out just from here. Unlike if you have if you have 4 here, you can just add x to it to make it degree 1. That's pretty obvious. Because when you're taking the derivative of 4x is 4. So antiderivative of 4 is 4x. But when you have 2 in the original equation, it's no way reflected in the derivative. So when you only have the derivative of that equation, there's just no way that you can figure out the antiderivative constant. So what we will do is we will use C, just C, and that's it. And then one last thing to wrap up. I'm not going to do a full problem on this. It's pretty self-explanatory. But say you have a curve like this. If you're trying to find how far the particle is from its starting position, you want to calculate the area of this, which is a triangle. You want to separate this into a triangle. Oops. And then separate it into square, because if you don't know the trapezoid formula, you might not want to do that. So then you separate that. You make that triangle. You make this a rectangle, and then another triangle up here, and you add up these areas, and then subtract from here because it's a negative. It's below the x-axis. Yeah, and also just to note, and that applies for if you have any kind of shape. If you have this, it's above the x-axis. If it's all above the x-axis, you're not going to subtract anything. You're just going to find the area. Maybe this is a square, or a rectangle. Sorry, or it might be a square. I don't know. Here, calculate the area of the rectangle. Calculate the area of the semicircle, which is just pi r squared divided by 2. Calculate the area of the triangle. And then one last thing I'm going to mention here: if you have a curve, you might not use Riemann sums for this. It's supposed to be just a smooth curve. I'm sorry about that. You might use triangles to estimate. Sorry about that. Just take what I say. Don't, this graph looks like I don't know, like there's rocks or something. I don't know. And if there were numbers here, you would do 1/2 times that times that, and do the same thing here. So that's all I have for you today. I hope you were able to catch up, and see you guys in the next one.